Hello guys, thanks for watching my video. Today we are going to solve an Euler-mascheroni constant and Riemann zeta function. That means the relation between Euler-mascheroni constant and Riemann zeta function. So then we are going to prove that the sum from n equal to 2 to infinity of negative 1 to the n zeta of n upon n. This zeta of n is nothing but the Riemann zeta function. Okay, so this whole sum is nothing but the Euler-mascheroni constant. Okay, so we are going to prove that. Now let me start with this one, left hand side. Let me call this or sum, infinite sum, to be s. So a is equal to the sum from n equal to 2 to infinity negative 1 to the n zeta of n upon n, so which is the sum from n equal to 2 to infinity negative 1 to the n upon n. Now one is zeta of n, so zeta of n is nothing but the sum from k equal to 1 to n, 1 to infinity 1 over k to the n. So this is the definition of this Riemann zeta function. Okay, now interchanging this sum and these two sum. Okay, as equal to sum from k equals 1 to infinity and sum from k n equal to 2 to infinity negative 1 to the n 1 over n times k to the n. So this is same as sum from k equals to 1 to infinity and sum from n equal to 2 to infinity negative 1 to the n 1 over k to the power n upon n. Right, so this is the same as this one. Now s equal to the sum from k equals 1 to infinity times, so if since this sum start from n equal to 2, so I like to start from n equal to 1. So when n is n equal to 1, from n equal to 1 to infinity negative 1 to the n 1 over k to the power n upon n. So when n is equal to 1 here, so this become negative, right? Negative, and this become 1 and this become 1, so it will be negative 1 over k. So we have negative 1 over k. So in order to cancel this negative 1 over k, we have to add 1 over k here, right? So now s equal to the sum from k equals 1 to infinity 1 over k minus, so this one if it take negative, okay, or multiply by negative this one, so negative the sum from n equals to 1 to infinity negative 1 to the n minus 1, so negative 1 will be here, add that or subtract, okay, here, so 1 over k to the power n upon n. Now 1 is this sum, so we have to see it. Now if you see the expansion of natural log that we have done, okay, already, so you see that this sum is nothing but natural log. Okay, so a is equal to the sum from k equals 1 to infinity 1 over k minus, so this whole sum is nothing but natural log of 1 plus 1 over k. Okay, so you can check out this expansion of natural log. So, and in the previous video also we have already proved that this sum approaches the Euler-mascheroni constant. Euler himself do this. Okay, Euler himself proved that this infinite sum approaches the Euler-mascheroni constant. Therefore, or s is nothing but Euler-mascheroni constant. Therefore, or s, one is or s is nothing but this one, or required to prove. So therefore, the sum from n equal to 2 to infinity negative 1 to the n zeta n upon n is the Euler-mascheroni constant. So this will be the proof.